Since the creation of heaven and earth, humankind has looked up at the sky and asked, could this be the home of the gods, the mighty, mysterious and powerful ones? This curiosity has led to progress for the sapient species in the following centuries. They began to create their own legends, beliefs, and started worshipping gods, telling each other stories about the supreme beings in the heavens. From the messenger god Hermes to the goddess of love and beauty Venus, humankind gradually discovered the planets. Any name of them after the stories they told each other. And then they found a red planet, a planet that embodied war, death, and destruction, and hence gave it a very suitable name, Mars, the god of war. Being the planet right next to Earth, Mars can be seen with the naked eye. Thanks to that, it has been recorded in the history and notes of ancient astrologers since humans started paying attention to the sky. In the 2nd century BC, Egyptian astrologers had somewhat understood the orbits of the star as it moved across the sky. Additionally, they also recorded the position of this star in the pharaoh's tombs like Seti, Ryamism as a way to document the sky. As pioneers in astrology, the ancient Babylonian astronomers also had their own discoveries about Mars. They invented mathematical methods to calculate the cycles of stars. In their records, Mars completed 42 zodiac cycles after 79 years, and he named the planet after Nagu, the god of war and plagues. Not far away, Chinese astrologers during the Zhou and Qin dynasties also recorded this familiar planet. Thanks to the Chinese records of the sky, the concepts of fixed star and wandering stars started becoming widespread. Fixed stars referred to the stars in the sky, while wandering stars referred to the moving stars. In the early days of astronomy, the concept of planet had not been born yet. Almost all astrologers called the bright dots in the sky stars, not knowing that it was reflected sunlight. The word planet comes from the Greek astrology word planetai, meaning the one word is initially used to refer to the moving celestial bodies including in the sun, moon, and other planets, clearly distinguishing them from the distant fixed stars that barely moved in the sky. And it was here in Greece, when Mesopotamian and Egyptian astronomy was imported and prospered, that the Roman and later Greek gods stepped onto the celestial bodies. And like the Babylonians, the Greeks also put their god of war onto this red star. Since then we have Mars. Not stopping there, as astronomical exploration technologies developed further, humankind gradually discovered Mars' 2 natural satellites and named them after the god of war's children, which are Phobos and Isolus. Mars is the 4th planet in the solar system, also the last terrestrial planet in this family. The distance between Mars and its star is about 228 million km. Additionally, between the terrestrial planets and the gigantic gas planets, there is an asteroid belt separating the 2 types of planets. Mars is the planet right next to this belt, causing the intensity of asteroid impacts to also be much higher compared to Earth. This leads to Mars' surface having many features similar to the Moon's, specifically the giant impact craters. However, that does not mean Mars only contains dangers and death. In planetary systems, the distance between a planet and its central star is extremely important to life. Being too close would cause burning, while being too far would cause freezing, both are not conducive to life developing. Therefore, the central area, not too close, but also not too far warm enough for water to exist in liquid form, is the most potential area for life to develop, called Goldilocks zone or habitable zone. It is located in this safe zone in the solar system. However, Earth is not the only planet here. Mars is also located in the Goldilocks zone. Therefore, it contains potential for life, something astronomers have plumbed onto to send spacecrafts here over the decades. In September 1610, Galileo Galilei started using the telescope to study Mars and brought new knowledge about the red planet to humankind. With a sharper eye, Galileo could discover the planet's cycles and calculate its orbit and mass. However, Galileo's telescope was still too rudimentary and could not bring accurate calculations. His successors absorbed the knowledge from their predecessors and wrote out more accurate calculations about the red planet. In 1659, Dutch astronomer Christian Huygens was the first person to draw a map of Mars based on his observations. In his map, he identified the planet's dark region, now called Ceres Major Planum by modern astronomers. Additionally, he also identified the planet's rotation period, estimated it to be around 24 hours on Earth, and preliminarily guessed the diameter and size of this planet by 1672. In the following centuries, discoveries about Mars through telescopes were continuously brought out, refuted and gradually updated. From there, hypotheses about life on Mars were also gradually born. In 1877, Italian astronomer Giovanni Schiappini used a 22 reflecting telescope to closely observe the Martian surface. Thanks to this telescope, he discovered giant channels on the planet's surface. He called them anomaly. These straight lamellae across the planet made him think they were artificial, impossible to be natural. However, anything too perfect is not real. Later, his hypothesis was refuted and determined to just be an illusion when observed by the naked eye. Although refuted, the hypothesis about life on Mars was not completely dismissed. On the contrary, it motivated many other astronomers to continue observing the red planet. Wanted to know more about Earth's sister planet, about what was happening on that red surface. Through the 19th century moving into the 20th century, humankind gradually made huge strides in science and technology. From astronomical observations, Mars' total volume is smaller than Earth's with a diameter approximately half of Earth's. Additionally, Mars' material density is also lower than Earth's, leading to Mars having much lower gravity compared to the blue planet. On the red planet's surface, gravitational acceleration is only 3.7 liters to 1 on Earth. It is 9.8 Nistor. Besides, with a wider orbit, Mars also needs more days compared to Earth to complete an orbit around the Sun. Mars takes about 24 hours 40 minutes on Earth to complete one day. A 1 Mars year is nearly 1.8 times 1 Earth year, specifically 1 year and 320 days 18 hours. Additionally, Mars also has an axial tilt close to Earth. Earth's rotation axis tilts at 23 degrees, while Mars is 25 degrees. Thanks to life, has 2 distinct seasons which are summer and winter, and so does Mars. Thanks to the tilt and distinct seasons, Mars also has ice at its 2 poles. However, this is not water ice like on Earth. It is dry ice or cut-through ice, with a farther distance from the Sun compared to Earth, coupled with a wider axial tilt. Mars' south pole has a permanent dry ice sheet spanning 400 wide and up to 8 thick. The ice sheet at the North Pole is even wider, with a diameter of 1,000 under suitable conditions. With the research done on Mars so far, it is not difficult for us to understand why this is the focused planet to be the next habitat for humankind. Mars is not too different from Earth, but just different enough that living on this planet is still a huge challenge. Nevertheless, nothing is impossible. Just give it time and technology will take humans everywhere. In the Cold War between the Soviet Union and US created a space race in the 1960s, which later created a fruit for astronomy. Starting from the 1960s, humans have sent dozens of spy Mars into the Soviet Union had a program called the Mars Program, comprising unmanned missions to send spy lost to Mars from 1960 to 1973. During this time, Soviet astronomers tested a limit launches to the red planet, starting with the twin Mars Queen, also called Marsnik by the press. However, this mission failed to enter Mars orbit. Competing with the Soviet Union, the US also had its own Mars program with the Polar Mariner 4 mission in 1965. His mission brought back the first those images of the red planet. However, the Soviet Union was yet inferior when it launched the twin Mars 3 out into space in 1979. The Mars 3 mission was the first one in human space exploration history that successfully soft-landed on Mars' surface. Viking 1 stayed and operated on Mars for a full 6 years, while Viking 2 only survived for 3 years. However, with that amount of information, humankind took huge strides compared to Galileo's time when observation was still only with telescopes. Up to this point, one may have a very optimistic view about the future of Mars missions. But reality has always been far from expectations. Going to Mars is one of the most difficult missions humanity has ever faced. The journey to this planet has been organized from the 1960s up until now, and the results add up to 60 of landing attempts have failed. Landing on Mars is no easy feat. Mars has a particularly nasty atmosphere, almost the nastiest among celestial bodies around Earth. With celestial bodies without an atmosphere like the Moon, the only thing needed is to bring the spacecraft there. Create thrust before landing, and the spacecraft will land as light as a feather. With dense atmospheric celestial bodies like Venus, the steps needed are creating a heat shield and deploy a parachute before gently landing on the ground. As for Mars, the story is twice as complicated. Mars' atmosphere is both thin yet thick, making landing a nightmare. On hand, Mars' atmosphere is too thin to deploy a parachute and land without thrust. On the other hand, Mars' atmosphere is too thick to use thrust without deploying a parachute. Therefore, for an unmanned spacecraft to successfully land on Mars, it has to have a heat shield to avoid friction with the planet's atmosphere during descent. It is to have a parachute to reduce speed when flying through the atmosphere, and it has to have thrust to safety without to the ground. And with that amount of equipment, a spacecraft to Mars would be much heavier than spacecrafts to other planets. From there, the challenge arises in balancing the rocket's thrust and the amount of fuel needed to carry. For these reasons, 20th century astronomers were always worried whenever thinking about bringing a spacecraft to Mars. But entering the 21st century, everything was gradually solved. From 2000 until now, 16 spacecrafts have been sent to Mars, and among those there were 12 successful landings, and currently there are still 8 spacecraft operating normally, continuously sending information back to Earth to prepare for humankind's next step of bringing people to the red planet. The first time humankind set foot on another celestial body was in 1969 when humans landed on the Moon. Since then, there have been many missions bringing people to space and back to the Moon. However, the 400 sunken distance is still too small. It's like going from home to the alley. Linking humankind to go out onto the highway to dream of a journey to bring humankind to Mars has long been proposed in astronomy's history. However, sending an unmanned spacecraft there is difficult enough, let alone sending humans. Nevertheless, with the development of technology and the promising mission since the early 21st century, astronomers have become hopeful of a mission to send humans to Mars. And then, Babulier joined the game. With the mission laid out to build up, although one may say this mission is just a publicity stunt, no one can deny the success of Starship, the first reusable rocket in human history. To bring a rocket into Earth's orbit, it has to balance between fuel and spacecraft mass. The heavier the spacecraft, the more fuel needed, and the more fuel added, the heavier the spacecraft. This makes launching rockets become a difficult math problem for space scientists. Cutting costs for launching spire with lasting to space will create a breakthrough in rocket science, helping humankind take bigger steps in exploring the universe. That is exactly what Spirings did, cutting launch costs by reusing parts of rockets already launched into space. From reusing rockets, SpaceX's Starship project can create commercial space flights for space science, can boost success for difficult trips to other planets, specifically Mars. However, cost cutting is still an extremely small step forward on a journey to Mars. To be able to send humans to the red planet, humankind still has to cross the over 2-year journey just to have a chance at landing. Therefore, from now until we can actually walk on Mars, rocket technology will probably need to develop even further. For now, Starship technology has started being used more. NASA has chosen Starship to support the mission of bringing humans to the Moon in 2025, and the mission called Artemis quote. First the Moon, then Mars. Humans will gradually develop newer rocket technologies and may be able to take bigger steps in their space journey. When can humans live on Mars, no one dares confirm. But we can be certain of one thing: nothing is impossible. And that was the story of Mars, the red planet of the solar system. as the place containing humankind's hopes for the far future. We can't help but look forward to the day that good news from NASA is announced, and we will officially take huge steps onto this planet. Are you excited about Mars? Let us know in the comments below. And if you enjoyed this video, don't forget to like, subscribe to us and click the notification bell, so you won't miss any future videos. You can also directly support us with the thanks button below the video. Thank you for listening and see you next time. Peace.